Hello everyone. So far we have covered the topics related to your midterm, and from today we will deal with the topics which are related to your final exam. I will talk about your midterm exam as soon as we will finish with this topic today. So what do we mean by counting? And here, as you see in the picture, this is a topic related to counting, which is named combinatorics. Counting is needed for us in order to solve many problems in nature, and as a mathematical reasoning, we can even use it for proving some theorems in mathematics. And for example, for the sets that you already know about, some of the sets are countable. It means that you can count the number of elements inside these sets. So for operations that we need for sets, for example, if we know there are limited number of them and they are countable, it's much easier to deal with them. Then we can define some rules related to them. Or the probability related to statistics. Then in order to define the number of possible outcomes, we need counting methods. So it's a very important topic. It's pretty easy for this course, and we will talk about the basics of that. And then I will talk about pigeonhole principle. In the next week, I will talk about combination and permutation, and also binomial theorem. First thing first, let's go through the basics related to counting. The first two rules related to counting are called product and sum. They are very similar to conjunction and disjunction logic. For example, for the product rule, suppose that a procedure can be broken down into a sequence of two tasks. If there are n1 ways to do the first task, and for each of these ways of doing the first task, it means that any way inside n1, there are n2 ways to do the second task. Then there are n1 multiply n2 ways to do the procedures. It's very similar to conjunction. It means that two cases should happen at the same time, and they are independent. It's very important that they are independent so that you can multiply them together and find the final answer. I will give you examples so that it will be much easier to understand. And for sum rule, it's very similar to disjunction. It means that instead of and, we have or. If a task can be done either in one of n1 ways or in one of n2 ways, where none of the set of n1 ways is the same as any of the set of n2 ways, then there are n1 plus n2 ways to do the task. What do we mean by that? That they are not the same in any of the set. It means that they don't have any intersection. I will talk about a rule after it, which is more obvious. What do we mean by sum rule after it? So let's go through the examples so we understand about these rules better. How many different bit strings of length 7 are there? So in order to answer such questions about number of ways to do something, all of them can be solved using counting methods. So for bit strings, assume that we have 7 of them, 1, 2, 3, 4, 5, 6, and 7. For each of them, what are the possibilities? We can have either 0 or 1. So it means that I will have 2 options for the first bit. What about the second one? Again, I will have 2. It means that, for example, if you have 0 for this one, does it have any effect on the next bit? Does this one force the next bit to be 0 again? No, it doesn't. That's why I call them independent. So whenever they are independent, it's possible to find the way that something is possible by multiplying each one of these possibilities or each one of these ways together using the product rule. It means that each one of them, they have two possibilities, and if you multiply all of them together, the final answer would be 2 power 7. What about an example related to sum rule? Student can choose a computer project from one of 3 lists. The 3 lists contain 23, 15, and 19 possible projects. So there are N1, N2, and N3 based on the formula that it was given. No project is on more than one list. It means that there are no intersection between them. How many possible projects are there to choose from? So by using sum rule, it's pretty easy to find the final answer. The only thing you need to do is to add them together. For the previous question, it was like we had 0, 1, and 0, 1, and 0, 1. So as you see, I use AND term, which is related to conjunction logic. But here we say this person will choose either from these ways, or these ways, or these ways. So how many ways are there? 57. It's not possible that the student at the same time choose one project from N1 and one project from N2. We will talk about the case related to intersection now. So what if we have intersection between sets? Like in the previous example, I had N1, N2, and N3 if I show it on Venn diagram. So there were no intersection between them. But what if I have intersection between them? Like I have a set A1 and I have another set A2, and you see they have some common elements here. In that case, in order to find the union between A1 and A2, I cannot just use this part, which is related to sum rule. I should also subtract this part, which is related to intersection between these two sets. Why is that? Because first, assume that I find the size of A1. So I count the number of elements inside A1, and then I do it for A2. And you see, twice I did it for this area, their intersection. That's why I need to subtract it once so that I will have exactly the number that I'm looking for. Let's go through this example to see how we can use that formula. How many bit strings of length 8 either start with a 1 bit or end with 2 bits zeros? So in order to answer that, I need to see what are the sets that I can define, or you can just define it as terms of number of something happening or possibilities. So this one and this one, there are basically two conditions that I have here. For the first one, so if I want to use the previous formula, I should consider the number of possibilities for the first condition, then second one, then subtract their intersection. So for the first one, I say start with 1 bit. It means that for the first bit, the only possibility that you have is this one. That's it. So if you want to multiply this one by the rest by using product rule, it means that this one is fixed. You just multiply 1 by 2 power 7, because there are 8 number of bits altogether, and this part contains 7 bits, and we already know why this is 2 power 7. So already we know the first part, we have 128 ways to do that. What about the second one? 2 zeros at the end. It means that you have fixed these 2 bits as zeros. So there is only one possibility here and also 1. It's like you're multiplying 1 by 1, multiplying the rest of the bits, which are 6 number of them. And you already know why this is 2 power 6. The final answer of this one is 64. And finally, we should calculate the intersection between them so that we subtract from these two possibilities. So here, I should at the same time consider both of the conditions. In the first bit, I will have for sure 1, and in the last two, I will have zeros. So what is left for me is 2 power 5, which is 32. So that's how you can calculate the union between these two sets. We can also simplify our solutions using 3 diagrams. I will talk about it in our last week. That's why I'm not going to talk about it today. But from now, you should know that this is also one way to deal with such questions. Like, for example, for the first questions that we had 7 bits and we wanted to give them 0 and 1s, we could start it from, for example, this is 0, this is 1. Again, for the next 3, I can have 0 and 1. And at the end, I will count the number of leaves that I have at the end of the tree diagram. Then we can know how many possibilities we have, in how many ways we can do such a thing. So we can also use tree diagram, which are very useful. We will talk about advanced topics related to trees in the last week. And when I say advanced, as the level of the book, of course. So the next topic related to counting is pigeonhole principle. I won't ask questions about pigeonhole principle in the final exam, but anyway, it's nice to know about this one, as it's mentioned also in your book. What does it say? It says that if k is a positive integer and k plus 1 or more objects are placed into k boxes, then there is at least one box containing 2 or more of the objects. So I have k number of boxes, and I have k plus 1 pigeons. So in that scenario, it says at least I should have one box containing more than 1 pigeons. Yes, that's, I think, pretty obvious. And the proof of all of them are in the book anyway. But what it says, it means that you can at least find one box containing more than 1 pigeons. Here, for example, for A, I have this one. For B, I have this box. And for the third one, I can even have boxes, not just one box. If you want to generalize pigeonhole principle, we can mention about this one, which is very useful to solve many problems. If n objects are placed into k boxes, so far this is the same case, then there is at least one box containing at least n over k, and you find the ceiling of that. Do you remember the sign ceiling? It means that if you have 2.3, if you want to calculate the ceiling of that, it should be, oh sorry, this part is extra. Then you will have 3, right? If you want to calculate the floor of it, then it will be 2. You remember that from one of the lectures that we had. So if this is the case, you can easily calculate it using this formula. As an example, among 100 people, there are at least this number of people who were born in the same month. And obviously, the condition that we should consider for this example is that all people have same probability for each month to have their birthday. It means that if someone is picked by random, it has 1 over 12 chance to be in, for example, to be born in January. So if we consider that condition, then yes, this is true. So as you can see, very easily we can answer such questions. Okay, guys, that was the topic related for this week. And for the next week, as I mentioned, we will talk about more topics related to counting, permutation, combination, and also binomial theorem. Please go through the chapter 6, especially 6.1. We should know about the basics of counting for sure. I won't ask any questions about pigeonhole principle, but anyway, it's not bad to know about this topic because we can solve many questions related to that one as well. Okay, guys, if you have any questions, please let me know. Otherwise, I will talk about midterm exam a little bit.